Today we are diving into the fascinating world of arrays and linked lists and exploring their unique attributes and how they operate. Arrays are static structures with a set size and fast direct access to any element via the index. This index generally makes searching faster due to the continuous memory allocation and better cache locality. Linked lists, on the other hand, are dynamic and flexible in size, making them ideal for situations where the collection size is unknown or fluctuating. Each node in a linked list holds data or a value, and then a next property that points to the next item in the linked list. Search time in arrays is generally faster, especially in a sorted array where they can utilize binary search and reduce the time complexity to O log of n. Linked lists require traversal from the head node all the way through until you find the node you're looking for, which makes the searching slower. Size is static in arrays and dynamic in linked lists. The static size of an array can be restricting, and the adaptability in linked lists offers more flexibility in managing collections of objects with variable lengths. Insertions are where linked lists shine, allowing for fast insertions and deletions, usually in O1 time, whereas arrays could take up to ON time. Arrays are much more efficient in memory storage because they have no overhead from pointers, whereas linked lists you need pointers with next properties and in some cases previous properties to be able to tell which element comes next and previous in the linked list. Here's an example of a linked list that demonstrates what I was talking about. As you can see right here, you have the head node, and then right here is the value of E, and it points to the next node with the data A, next node B, next node C, next node D, and the tail node points to null. So why it's faster with insertions and deletions, let's say that we would want to add a node in here between B and C. So what we would do is we would just change the next property from this one to be F up here. So we would point to F instead, and then F would point to the C. Or if we want to delete like the item C, all we would have to do is just move this next node right here and just skip over it to D. And then in theory, C would already be gone because nothing points to it. But where the disadvantages would come in is if we were trying to index and find C, we would have to start at the head node and then go through all of the next properties until we get to C. Whereas with an array, it is a lot more efficient because you don't have to jump between every single node by the next property. And those are some of the differences between linked lists and arrays. Let me know if you want me to cover the syntax of linked lists and some of the methods on arrays in a future video.